you can see my screen now. So we'll be starting with the question today. So the question that we'll be starting with is this. From this show command on the screen, show spanning tree VLAN 1. Um, is this switch the root bridge on this network?
No.
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 What about, okay, yeah, no, okay, yeah, okay. So let's go for another
I
one.
can tell you two things. Maybe it will help somebody.
Let's go. We'll see. Let's see again. Let's do show spanning tree VLAN 1. What about this switch? Is it the root bridge on this network?
No.
Mm,
Yeah.
no, that's forwarding. No.
No. Okay. So let's go to another one. Go another one.
You are prepared well, huh?
Spanning tree
It's missing. You
VLAN
spelled
1.
tree wrong.
Just 1 minute. Let me mute this stuff.
You put triple E.
Baby, can you please mute your phone? Yeah. Okay. Yeah. Sorry. Mistake.
What time is it where you guys are at?
It's 5:40 in UK.
Yeah, that is the root part.
Yeah.
Oh, no, 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 no. You just change it.
So
Ah, that's not this one. You
not
just
this one.
switch that.
Okay. So let's go back to this one. So
This is
this is the
yeah,
root switch.
yeah,
So
yeah.
my question is, how do you know?
There is, if you go to first paragraph, you
Yep.
see root ID, and then you check the MAC address of the root. Yeah, yeah.
This one.
And then if you go to down bridge ID, the MAC is matching. The other thing is,
Hmm.
if you go down in the last section,
Hmm.
the both of the ports are in designated and forwarding, and that is the first thing that once the switch is a bridge, a root bridge,
Hmm.
it's all port are designated.
Hmm. Okay. Yeah. Then what else?
What else? The priority are defaults, and it's for VLAN 1, and the cost is 1920. Yeah, that's okay. That's
Yeah. Any other any
there.
other any other one, Mark? Any other indication that you can use to tell that this is the root bridge?
I think he said everything that I can think of.
So you think of the MAC address is
Yeah,
equal. All
equal.
the
Yeah,
ports are in designated row,
yeah.
All
and
right.
the one that is most obvious.
This is the root bridge. Yeah, yeah, yeah. I saw it straight
Yeah,
off.
okay, yeah, sorry, yeah. Powell already mentioned that. Yeah, so
Yeah.
exactly. So this bridge is the root. So that's like because yeah, Cisco might ask you something like that, like where they ask you to say like how do you which one how can you tell this one is the root bridge or something like that. Who knows? Okay, so let's make a bit of progress from last time when we discussed spanning tree. So the last time we were discussing spanning tree, we discussed just the fundamentals and the basics. So if I go Cisco switch and let's just bring the image up. Um, and by the way, just to mention, spanning tree is one of the things that, as network admins, we have to absolutely nail it. We have to absolutely understand it. Um, Unfortunately, it's one of the things that could be a bit tricky when you're troubleshooting, because troubleshooting spanning tree problems in a network can be really, really tricky. But it's one that we have to absolutely understand as network engineers. Okay, so let's actually just make this one smaller. So we have smaller. So we have a Cisco switches here. Let's delete that. Let's delete this too. Let's delete this one to replicate this one. So we have one here. We have two here. We have two here. So we have these three switches here. Um, we have this guy connecting here. We have this guy connecting here, and we have this guy connecting here. Just to reiterate a little bit of what we discussed last week. So you have these three switches connecting to one another this way. And this in a production network, this forms something. This can form a loop, right? So
Yep.
yeah, so is there any reason why we need spanning tree at layer 2? Just to revise a little bit from last week. So what's the reason why we need spanning tree at layer 2?
Prevent loops.
Yeah, prevent loops. And why do we need another protocol, a special protocol? I mean, we don't have, spanning tree at layer 3. Why don't we have spanning tree at layer 3?
Because it's a switching problem, not a routing problem.
So why is it a switching problem, not a routing problem? Why?
But also there is a routing problem as well. There is a we have a routing loop as well. So we put it as well.
Yeah, I mean,
VRC
yeah.
and
I mean, we have routing loop, it's true. We have routing loops, but what we don't have is we don't have a special protocol to stop routing loops. You know, normally, routing loops, you just fix it with
yeah,
configuration.
algorithm. Are you talking about algorithm?
Yeah. So we don't, spanning tree is a special protocol that it has only one purpose, to prevent loops, like what Mark said, to prevent loops at layer 2. But at layer 3, we don't have a special protocol dedicated to present. Thanks for, yeah, Powell already answered the question. So if you look at Powell's answer, because in layer 3, we already have sort of like a loop, um, well, not prevention, but a loop stopping mechanism.
Because in switching there is no time to live. It's
Exactly, good one. So that loop stopping mechanism is called what? Time to live. So what that means is this: you have a PC connected here. So there's a PC connected here. This PC says, okay, you go to your web browser, you bring up, say, I want to go to this website. Let's say the website you're going to is on a server that's on your network. Maybe the server is connected to this switch somewhere. So this guy is like, oh, I want to go to the address of this server here. So what will happen is the application will create a packet, right? And in the packet, it will create an HTTP GET request. So I want to get a web page. So it's going to say, okay, I'm creating this packet. And at the end of the packet, it's going to attach, when it's going out of this network interface, it's going to attach the source IP address, right? And the destination IP address. Is that right?
I
Yeah.
think so.
Yeah. So it's going to say, okay, I've got the source IP. Well, it looks like SIP. Let me say source IP. And in front, there's going to say, okay, I've got the destination
I
IP
think
there.
it's first destination IP and then source IP, no?
Yeah, you're right. But this one I'm just using it for illustration to bring something out. So you got the source IP, you got the destination
Okay.
IP. Then it's going to, of course, get like the source MAC address, destination MAC address that it's going to get. Then it's going to send this out from this. So it's going to send this out to the switch. So when it gets to the switch will look at the source MAC address, right? And the destination MAC address. So source MAC address to see if I need to put it in my MAC address table. Destination MAC address to decide where do I need to forward it to. And then it forwards it based on that. But if it's going to go all the way to a router where you got source IP, destination IP, when it gets to the router goes, okay, you're going to this destination IP, I'll forward you out this way. If there happens to be a loop at layer 3 where there's a router, the packet will go out. It's a packet, not a frame. It will go out and then come back, assuming these are routers, and then go here, and then go here, and then come back, and then go here. But as it's transversing different ops, the time to live exactly is decreasing. Exactly. Thanks very much, Powell. So the time to live is decreasing. So the time to live, when it gets to that point where the time to live expires, the packet will be dropped. But in layer 2, there's nothing like this called time to live. The frame will just keep going round and round and round and round and round. And what's the way to stop that frame from going round and round?
Spanning tree.
No, apart from spanning tree, I mean, if a loop has already occurred, how do you stop it? How long will the frame keep going before it stops?
Until you disconnect the one port.
Exactly. You're all right. Powell is right. Imran is right. Until you either disconnect the port, shut down the switch, or shut down the port, the frame will just keep going round and round and round and round and round. It won't stop. So that's why at layer 2 we need a special loop prevention mechanism. Another thing that happens is that many routing protocols support multiple paths, right? For example, assuming this, actually let's make it clear. Let's go this one and let's bring up router. Assuming in the picture what we have, assuming it's not Cisco switches, assuming what we have is Cisco router. And assuming what we have is let's get a really good one. Yeah, be this one. Yeah, assuming what we have is this one. Uh, so let's go. Assuming what we have is a situation like this where we have three routers that are connected in this way, and this one is going connected here. This one is connected here, and this one is sorry, and then this one is connected to this guy over here. And assuming you know this one on your network, you can go via this router. Let's call this router 3. Let's call this router 1. Let's call this router 2. You can go via router 2 to get to router 3, right? And you can go via router 1 to get to router 3. If you have this kind of a situation and router 1 goes, I can go via router 2 to get to router 3, I can just go directly to router 3. What can happen in this situation is a router has a way to do the routing protocol, or many routing protocols have a way to do load balancing. Where if you go to OSPF and you say show IP routes, OSPF can tell you I have two paths to get to this router. I can take part 1 or I can take part 2. And actually it can be using both paths at the same time. Where you can send, one package to router 1 to router 3 directly, one package to router 2 to router 3. It can load balance both paths, together. It's inbuilt into many routing protocols. OSPF is a good example of that. But yeah, exactly, Imran. So equal cost load balancing, or even not that. I mean, many ways that routing protocols can handle that. But on the switch level, on the layer 2 level, this is not inbuilt. So that's why we need a special protocol to handle this. And then after we discuss this, we discuss that how the way spanning tree works. So in this situation now, what will be the first thing that spanning tree would do? So this is just still revising from what we discussed last week. So Mark, if spanning tree wants to work, what will be the first thing it would do?
Why am I showing my screen here? Oh, the first thing it needs to figure out the route, right?
Exactly. Figure out the route. And what does it use to figure out the route?
The MAC address,
MAC address.
priority.
Which one first?
Which one first?
Yeah,
I
MAC
think it was the
address
MAC
one.
address first, wasn't
Imran, what do you think?
it?
Yeah,
Okay, that was
They,
wrong.
they will send out the BPDUs stating that they are the bridge. Everybody will send that this is my info, this is my bridge ID, and I am the root bridge. And when somebody will get the lower bridge ID, then he will stop advertising himself and he will start advertising the other guy who is lower in the priority.
excellent, Imran. And your part correct, Mark, actually. Because what it's actually going to use is something called the bridge ID, which is a combination of the priority plus the MAC. But actually, the priority is like the top one that it's going to be using. So it's going to be looking for which of these switches has the lowest priority. That's what it's going to be looking for. Which one has the lowest priority? And by default, what's the priority on these switches by default?
32,768.
Good one. 32,768 is the priority by default. And if I go here, got 32,768 by default. And then let's like the example that we used the last time. Let's say this is AAA. Let's say the MAC address of this one is BBB, and then the MAC address of this one is CCC. So after it does that, which one will be the root bridge in this case?
A.
A will be the root bridge because A has the lower bridge ID because they all have equal priority, but then they have the same MAC. But what happens if I change the priority of B and I change the priority of B to 4096? Which one will be the root bridge now?
This is the lowest priority 4096.
Yeah, exactly. So the priority actually takes higher priority if you want. So, so the priority, yeah. So although it's a combination of the two that it uses, but the priority takes more. It's more important in terms of that. So after it figures out the root bridge, what's the next thing that it's going to do, Mac? So I figured out the root bridge. So so they've all agreed. Switch B is the root bridge.
Isn't it the cost of?
He will run the algorithm.
Yep. And what would the algorithm be doing? What's the algorithm doing? What's the
He
figure?
will calculating the path and
Good one. The next thing is that, okay, if this one has said I am the root and everyone has agreed on the network, you are the root. Then all the other switches, the next thing is we are going to begin to calculate what is our best path to get to the root. That's the next thing. So like we've all agreed you're the root. The next thing that the rest of us that were not the root, the next thing that we're doing is what's the best way that we can get to you. So the root is now like the reference point of the rest of the network. All the other switches, first thing they come together, they say let's select, this leader. Like, yeah, you're the leader, you're the root. Then the next thing is let's figure out. I've got many ways to get to you because what will happen is switch C will go. Switch C will receive an advertisement from switch B. And the advertisement from switch B will say, I am the root bridge, right? But at the same time, switch C will receive an advertisement from switch A. And the advertisement will be switch B is the root bridge. So switch C goes, okay, hold on. I can reach the root through two ports on myself, right? Because I can hear the advertisement from this port and I can hear the advertisement from this port. That means there's a loop somewhere because I can reach the bridge through two ways. So the next thing that is going to begin to do is that, okay, since I can reach the bridge through two ways, which one is the best way for me to reach the bridge? So, and every switch on the network will begin to calculate that. What's the best way? So all non-root switches, yeah, good one, Mark. All non-root switches calculate the best path to reach the root. And what do they use when they are calculating the best path?
Bandwidth and isn't it, or the type of connection?
There's something that is called. I mean, there's a particular that the exact thing that they use is called something. What do they use? You're right, Mark. When you say bandwidth, it's bandwidth. When spanning between language, it's called something. Imran, do you want to chip into that? So what do they use to calculate the best path to get to the root?
take
Look at this. Now let's go back to packet tracer and let's go show spanning
It's
tree.
cost, but it's something else, right?
You're
Administrative
actually
cost.
right. It's cost, but it's called path costs.
Oh, path.
oh yeah.
So it's called path costs. So that's the next thing that they're like, okay, the path cost. So how is the path cost? How is it determined? So what's the path cost if I've got a 10 meg link? So these are all revisions from last week.
It's 100.
100. What about if I've got a 100 meg link?
Then it's 19.
19. What about if I've got a 1 gig link?
4.
Oh,
4.
4.
Good one. And then what if I've got a 10 gig
Two,
link?
two.
Yeah, good one. Thanks. Thanks very much for that. So then, so these are like there are many other um values, but this like the one that is necessary for CCNA. They've got for all types of link that you can think of.
How did they
But
come up with such an obscure number like 19?
yeah, exactly.
Uh,
They even got all these ones are actually calculated by dividing the bandwidth with a reference of 1000.
oh, okay. So
Yeah.
it
So
actually has a meaning to it. It's not.
yeah, yeah. Before it's not this way before. Normally, like before, 10 gig used to be 0 because the
Uh,
reference was 1000. Then after, but then they changed it, so now it's 2. Okay, so they use that to determine what's the best way. So if C determines the best way for me to get to this route is this one, is this port. Let's label the ports also. So let's go, this is port 1, this is port 2, this is port 3 here, this is port 4, this is port 5, and this is port 6. So it's like, okay, best way for me to get to the root bridge, which is B, is through my port 4. And this one determines the best way for me to get to the root B is through my port 1. So those ports, they will be they will be put into a particular um, port role. So what's the role of that port called? So
forwarding.
so now we're now yeah, we'll get to that. So that yeah, we'll get to that one in a bit. But it's
Oh,
a particular type of port. So this is like actually answering the question that Imran is mentioning.
It's designated. Both port that connected to the root switch are designated,
That
and
yeah,
the port that are going directly to the root bridge, it's a root because they have the least cost to reach the root bridge.
yeah, you're right. You're right. Mark, do you want to add anything to that in terms of because now we're getting a bit into today's discussion, which is number one. Let's talk about spanning tree port roles. So spanning tree has some particular port roles that it uses, and those port roles, you have the root port, you have the designated ports. Which other ports do we have?
Uh, Non-designated or block port.
Yeah, block port. Any other one?
um,
Disable.
So let's make this one clear. So they are when you're talking about spanning tree, there are different things. So when you're talking about spanning tree port roles, is different from spanning tree port states. So they are different things. So let's so we have spanning tree port roles, we have spanning tree port states. Spanning tree port state is the one you're mentioning where we have disabled. What else do we have in spanning tree port state?
Learning, listening, forwarding.
Yeah, blocking, learning, listening, forwarding. So if you go back to our packet tracer, you can actually see it from here. So you have port row, right? And then you have
there's, it
port what? State.
says there's a disabled state too.
So yeah, exactly. There is a disabled state, but we'll talk about that one when we get to state. So again,
Okay.
remember we have port rows and we have port states. So there are different things. Port rows, port state. So the port row, first one we said the root port. So remember that when we said um, after the root bridge is selected, all the non-root bridges or all the non-root switches will start calculating the best port that they can use to get to the root, right? When they decide that port will be the root port. In other words, the root port is the port that I have chosen to take me to the root bridge. So that's why it's called the root port. I'm not sure if that is clear. And there can only be one root port let's go one root port for every non-root switch. So all the other switches that are not the root switches, that are not the root switch, they will determine one port that they will use to transfer traffic to the root, or the best port that they can use to transfer traffic to the root. And that port will be put into the root port row. I'm not sure if that is clear.
Yeah, it is. I mean,
Yeah. So for
it's kind of
example, if we go back to this one, so we've got a switch 0 here, which is not the root. Um, okay, yeah, it could be the root. Okay, we got this one here. Let's go example, show spanning tree VLAN 1. So you can see port FA01 is being elected the root port on switch this one. FA01. So that means if this guy wants to get to the root, he's going to go out of this port, FA01. So that means this is the port that if I go out of this port, I'm going to the root. Or this is the port that I've determined is the best way for me to get to the root. And there can only be one for every non-root switch. So you can only
so
have one. Yeah, carry on.
it'll basically show you which direction the traffic is flowing, packets are.
Exactly. So it's going to be like, this is the port that I'm using to get to the root. I mean, I can get to the root through multiple ways, but I have to determine only one. I have to decide and pick one. So that one that I pick will be the one that will take me to the root. So that's the root port. Imran, is that clear?
Yeah.
Yeah, okay. So that's the root port. Then we've got the next one, which is the designated port. Now, for the designated port is this. One way that I've used to understand it is um, designated port is moving away from the root.
Yeah, the one side, if one side is root, the other side should be designated.
Yeah. Or let me put it this way. Now, let's go back to this diagram. So if this guy has determined port 4 is the root port, right? Let's put RP next to it. And this guy has determined port 1 is the root port. All other ports on this switch, or all other ports, will be designated, but that's not actually accurate, because the way it will happen is there has to be one designated port, at least one designated port for every segment. Which is why Imran was mentioning that it could be a bit complicated to understand, right?
Yeah.
Yeah, because okay, let me put it this way. This one is the root port, right?
Yeah.
This one is the root port. Now, for this segment here,
It will
for
be.
every segment there has to be at least one designated port. There can be more than one designated port, but at least there has to be at least one designated port for every segment. So for this segment here, they have to decide which one of them will be the designated port. And which is why there has to be another election where they elect um, which one will be will be blocking, which one will be forwarding, and all that. Imran,
Yeah,
yeah, carry on,
yeah,
Imran.
they will look for the port priority, and if the default is the same, then they will go for um, the lowest port number, or is it in the last? I'm confused here.
So, yeah,
There are three rules actually.
yes. So that one, yeah, we'll talk about that one too when we get there. So, but for this one, when we talk about designated ports, it's it's um because the reason why one of the ways, like, I know, for example, my instructor in London, the way I explained it was that the port that is moving away from the route. For example, if you look at the route bridge, all the ports on the root bridge are designated ports, right?
Yeah.
Because it's moving away from the root bridge, right?
Yeah.
Because this is the root, I'm the root, so all the ports on me are moving away from me. So this one is designated, and because this one is moving away from me, this one is designated. But when I was thinking about it, I'm like, that's not particularly accurate because you can get to the root via this port also, right? So it's not
Yeah.
particularly moving away completely from the root because it can still move towards the root directly. Sorry, indirectly. But what it meant by that is this. Once the switch selects this is the port that will take me to the root, and it has the root port, what that means is that the other port will take me away from the root. I'm not sure if that is clear.
No, 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 it's
No.
not.
Power version, lower port number. Yeah, yeah, we get that. So we're talking about like the designate, but okay, you eventually pick it up, Imran.
Sorry?
Imran, I said let's see. Powell is mentioning some parts are concerned if you have at least two link between switch not bundled together. But yeah, exactly. Okay, so that's like Powell is just trying to answer the question that you mentioned. I don't think that is clear to Mark also, right?
Um,
It's a bit fuzzy, right?
yeah, a little
Yeah,
bit.
yeah. Because one thing is just realize that for every segment there must be a designated port. Or let me try to do something. Let's go paint. So if I've got a switch here, a switch here, a switch here, a switch here, and this switch are connected. This one connected here, this one connected here, this one connected here, this one connected here. This one, they all have default MAC address. So this one is AAA, this one is BBB, this one is CCC, this one is DDD. Yeah. Um. So they decide A will be the root bridge, right?
Yeah.
So B, C, and D must decide what's the best way for me to get to the root bridge, right? So all these other three must decide what's the best way for me to get to the root bridge. So I got my wife here. Sorry, just a minute. I got I got my wife disturbing me here. Can you please help me to switch off the heater a little? Mm, because of the noise, car. Sorry. Yeah, yeah. She's disturbing me.
David's in trouble. He did it.
So she's
Kevin, I thought you are still single because I have very, very problem with my wife.
yeah. No,
It's
she's having.
difficult to get a time from her, so it's a lap time. I want to do that.
Yeah, you're
But
right.
then,
That's one of the reasons why she's on my case now. Cause she's like, yeah, you're spending time with these people on the internet. Just let me go a little bit. Yeah. So okay, we got switches A, B, C, and D. So A has the lowest MAC address, so A is the root bridge. So switch B, C, and D, or switches B, C, and D must decide which one or which port is the best port for us to get to the root, right? So,
can you just share the screen
oh,
of
sorry. Yeah, let's go screen share again. Sorry about that. If I go
no
screen
problem.
share. Yep. So you can see my screen, right? Yeah, you can switch it on again. Actually, you can switch on the heater.
Yeah.
Yeah. Okay. So go port one, port two, port three, port four, port five, port six, port seven, and port eight. Okay. So A is the root because it's got the lowest mark. They all got the same priority. So B, C, and D decide which port do we use. So the port all have the same links, right? They all have the same path cost, the same link. So for port B, which port will be the root port? Oh, sorry, for switch B, which port will be the root port?
For which one? B?
For switch B, yeah.
Uh,
Assuming everything else has the same um,
two.
path cost.
Two would be the root, right?
Why will 2 be the root port?
I forgot what you just said about
Because it
that.
has the lowest path cost to the root
Exactly, the
bridge.
lowest path cost. Because for example, let's say this is a 100 meg link. So this port, this part is 19, right? This is a 100 meg link. This part, let's say it's 19 also. Actually, that's not the way to calculate it, but just so we can use this as illustration. So this one too is 100 meg, so this part is 19. This one too is 100 meg, so this part too is 19. So this one will be, if I want to get to switch A to my port 2, it cost me 19. But if I want to get to it through my port 4, it's going to cost me 19 plus 19 plus 19. So the lowest always win in spanning tree. So it's going to be, well, the one that I will use to communicate with the root will be port 2, which will be the root port, right?
Hmm.
So switch D, what will be the root port for switch D?
For switch D would be the 1919, so they have equal. So they will be 6 will be the root port.
Why? Why will 6 be the root port?
The answer is by Pavel in the chat. You can see he say it's a lower port number because they have equal cost path. Then they will go for priority. If it's pure default priority, then in the end, if this is tie, then they will look for the lowest port number.
Which
And
lowest port number?
6 is lower than 8 on the DDD.
Powell, do you think that's right? Powell said I haven't answered yet. Powell, do you think that's right? Mark, do you think that's right? Which one do you think will be the root port for switch D? The reason why I'm bringing this one up is I'm thinking maybe it can help us to understand designated port role. But which one will be the switch port for, sorry, the root port for switch D? Which one will switch D go?
I say 6.
Okay, Powell says 6, but Powell says the explanation is not right. So actually, what Powell said is right. So Imran, you're close, but the port that it's using is not the port on the switch itself, it's the port from the advertising switch. So it's gonna be like, okay, if I go this way, it's gonna cost me 19 plus 19, right?
Mhm.
Which would be 38, right? So it's gonna be if I go this way, it will cost me 38. If I go this way, it will cost me 38. But it's gonna be
Yeah.
like, okay, this switch that is advertising to me, the port is the port that it's using to advertise is port 7. Why this
Okay.
one that is advertising to me, the port that it's using
That's
to
the
advertise
fourth.
is port 4. So this one
Okay.
is lower, so I will go with this one. So that way, so power, am I right or am I wrong? Because it's been a while now. So this one will be the root port. Yeah. So okay, yeah. So I'm not sure if that's clear. Power says I should swap 6 and 8 and then ask the question again. Okay, yeah, let's do that. Let's go. Let's go. Let's delete this. Let's delete this. So let's say this one. So Imran will go to you again.
Okay.
So this one is 6, this one is 8. And then which one will be the root port?
Uh, yeah, then I will go with the 6.
Why?
Where CCCC, because my logic was that because it is connected to the lowest port number, it will win.
But that's not right. Because the 1 will still be 8. It will go via 8. Because it's going to be
With
using the port.
advertising port,
Yeah,
okay.
the
You get it
advertising
together.
one. Yeah, it's going to be using the advertising one.
Okay.
Not the one on me, the one that I'm receiving the advertisement from.
Okay.
So if I go to this one, show. Ah, Okay, Powell. Oh, okay. Yeah, actually, yeah. That's right. Yeah, that's right. Sorry, I've made a mistake there, guys. So, um, in a situation like this, where you got two parts, two advertisements, right, from that are equal, the next one after the part cost, if the part costs are the same, the tiebreaker will be the bridge ID. So the one that has the lowest bridge ID is the one that I will go for. So if B is advertising to me, it's got a lower MAC address than C. Or sorry, lower MAC address or lower priority, it doesn't matter. So it's going to be, sorry. So is that clear? So in this case, let's say they have default, the answer will be B. This one will be the root port because this one's got the lowest priority. Is that clear?
But I
So,
think there are three rules: path cost, bridge ID, and the lowest port
so
number, right?
that one is will be in a situation like this one down here. So the one I'm actually mentioning, it's right, but not for this scenario. So what Power mentioned is right. So the one that I'm mentioning is right for a situation where you have two switches like this, where this one is,
Oh, yeah,
yeah,
yeah.
where this one is AAA, this one is BBB. Now they both have the same priority, but let's say this one now is now the root, right? Now this one decides, oh, I've got port 1, I've got port 2, I've got port 3, I've got port 4. But this one is like, okay, if I decide that port, because now if I go via port 3 to get to the root, it will cost me the same thing, right? If I go via port 4, it will cost me the same thing. So what will be the tiebreaker? The tiebreaker in this case will not be bridge ID because the bridge that is advertising them is the same. So the tiebreaker in this case will be the port, the advertising port. So what I said is still right, but it's right for a scenario like this. So the bridge ID goes first before the advertising port number. Is that clear? Mark, what do you think? Is that clear?
Clear as mud.
No, Daryl, you are putting advertising port number at the end, right?
Yeah, at the other hand.
But when I see priority plus MAC, bridge ID,
Hmm.
because if everything priority is the same default,
Hmm.
but after the MAC it cannot be tied because MAC is a unique.
Yes, but in a situation like this one down here, you remember the mark is tied.
Yeah,
Yeah, so in that case, it will be advertising port number. In a situation where you have two switches with two cables connecting them, do you get it?
yeah,
Because this one is still a loop, right? But this
yeah.
one, if you use the path cost, let's say this one costs you 19 and this one costs you 19. So the path cost can be the tiebreaker. So the next one will be bridge ID. Well, the bridge ID is coming from the same bridge, which is AAA, and the same priority. So the bridge ID can be the tiebreaker. So the tiebreaker will be the advertising port number, which will be, in this case, 1. Is that clear, Imran?
Yes, yes, yes,
Yeah.
yes.
Mark, is what is not clear there? Give me, throw the
No,
question.
I mean it kind of makes sense, I guess,
Yeah.
what you're saying.
Yeah. So okay, let me give Mark a question. So I'll see whether Mark has really understood.
Oh no.
So let's delete this one. Let's delete this one. So let's say this is port um this is port 12 uh, and this is port 2. So which one will be the root port for switch B? In the scenario below, not in the scenario above, in the scenario below.
Uh, which one is the root port?
Yeah. So let's go through it together, Mark. Let's go through it together.
Okay.
So what's the first thing that is going to use to determine the port that I will use to go to the root? What's the first thing? Start from the beginning here.
Path cost.
Path cost. So the path cost in this one is what? 19.
19.
If it goes through port 4, what's the path cost again? 19.
19.
So the path cost is the same. So it moves to what?
Bridge ID.
Bridge ID. Bridge ID of the advertising bridge. So the advertising bridge is the same advertising bridge, which is the MAC address is the same, the priority is the same.
All right.
So can he use the bridge ID to decide what's the root port?
No.
Because the bridge ID is the same. So
All
then the
right.
next thing will be what?
Advertising port
So
number.
which advertising port number will he use in this case? So which port will he pick based on advertising port number? Which port will he pick?
I mean, how does it pick it by the lowest? Is it?
Yeah. So in spanning tree, always remember this rule. Always, 100% of the time, lowest always wins. Always. So in this case, which one will be the root port, do you think?
2.
No, because A is the root bridge, so port B has to decide either port 3
Oh,
or
which one
port
is
4.
of that? Okay, so 3.
3. Why 3?
Well, that's the lowest of the 2 port numbers, right?
Hmm?
No.
Imran, what do you think? Which one will you
Ugh.
pick?
Sorry,
Which
I
one do you
didn't get
think
it.
you will be? Which one will be the root port for switch B?
Switch B for the lowest, and that will go to root port number 4.
Number 4. So can you help to explain to Mark why is it number 4?
Because 12, port number 12 is bigger than number 2, and we see advertising port number, so
Yeah. So
12.
so do you understand it better, Mark? So it's not using the local port number on the switch, it's using the port number that is advertising it. So it's like I'm
Oh.
receiving an advertisement from port 12,
Mhm.
I'm receiving an advertisement from port 2. So it's going to be like 2 is lower than 12, so I'm going to take the one that 2 is telling me.
And use that path.
Yeah.
Okay.
And that one will be so it will be like, this will be my root port to get to the root bridge. What about a situation like this? What about if we change this around a bit? And so this one will go to Mark again. So let's delete this one and say this port here is port 1, and this port here is port 2. So which one will be the root port?
I mean, if it uses the root, it'll be 1 because that's the lowest one. So 3 would be.
The root port. And why is that? Why is it not 4?
What's that?
And why is it not 4?
Because it's using the advertising. You said the advertising
Exactly,
port.
exactly. So remember that it's not the local port that counts, it's the port that is advertising it that counts. Is that, I'm not sure, is that clear?
hmm
I'll tell you one secret is that in a view live network, because you might be thinking, how does this apply in a view live network? In a view live network, this really applies. But I tell you, one of the best things is spanning tree is a good reason to always have network diagrams. Because otherwise, you as a network engineer, you have to be able to put your network diagram down on paper and figure out what is my root bridge. We'll get to ways to manipulate it later. But spanning tree is like a good reason to have a good network diagram. Because you must be able to quickly look at it and say, okay, this port is going here, this port is going here. You need information like that.
Yeah.
Yeah. Okay. So we got that. So in this case now, so again, let's delete this one. So Mark and Imran, which port do you, so let's delete this one. Let's change it everything back to confuse it up a little bit. And then let's see if we can figure out what the root ports will be. So let's say this one is back to 8 and this one is back to 6. So what will be this root port for switch D?
Now I know
So what? Yeah, go ahead, Imran. Which one?
that the number 6 will be the root port, because for number port on BBB
Hmm?
is less than port 7 on CCC.
Mark, what do you think?
Yeah, I think that's
No,
correct.
wrong, 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 wrong.
No, wait a minute, wait a minute. Let me rethink. Um,
Right answer, wrong explanation. Again, remember, we have to go through these three. First
oh,
one is part cost.
Ah,
Remember? Then after part cost, what's the next one? Bridge
bridge.
ID. Then what's the next one? Advertising port number. So you have to go through this process when selecting the root port. So first one is the part cost. If the part cost is now equal, then the next one that it chooses is what?
bridge
Is the bridge
ID.
ID. What's the bridge ID of this switch that is advertising?
Oh shit.
Yeah, you understand now, Imran.
Yeah,
Yeah, so
yeah,
let's change it. Let's change it around a bit.
yeah.
So
True,
let's
true,
change it
true.
around a bit. So let's go. This is BBB, and let's go. This is CCC. So which one will be the root port for switch T?
For switch D,
Yeah.
should I tell you?
Go ahead. Go ahead and tell me.
Oh, then it will win 8, number 8.
Number 8. Why?
Why? Because the Mac is lesser than the Mac advertising on the CCC.
Yeah. What do you, Mark? What do you think?
I think that sounds right, but if the MAC address is lower, does it stop there or does it?
There, it stops there. So
Okay.
if the mark is like, if I can determine a winner based on the mark, I don't go to advertising port. So in that case, advertising port number will only apply to a scenario like the one below, because that's the only time when the mark, when the priority or the breach. Again, remember that this is not just the mark. This is the priority plus mark. So if the
Right.
priority, so okay, let me even make it a bit more interesting. So let's say the priority of this one is 4096, while the priority of this one is 32768. So which one will be the root port for switch D?
Oh, jeez.
It
Then it will be the 6.
will be 6. Why?
It has the lowest priority
Exactly.
than the B.
Exactly. So Power wants me to even make it more confusing for you guys.
But it,
Power says now change the cost between 1 and that to 100.
so does it have to have the lowest MAC and priority, or
No, yeah, so it has to be so again, it's the bridge ID. Bridge ID is priority plus mark. So priority goes first always. So in spanning tree, it's not actually so actually we can reduce this one. You know how to break it down a bit to say first thing is part costs, the next thing is priority, the next thing is mark, the next thing is advertising port ID. You get it? You get it?
yeah?
Yeah. So we can break it down. So when we say bridge ID, it's priority plus mark, but priority is first.
Okay, I see.
Okay. No, power, power wants me to make it even more confusing for you guys. And power wants me to change the part costs. Okay, let's do
Yeah,
that.
do it, do it. Let's test. Test is good. We'll
Let's
sleep
do
good
that.
tonight.
So, but the thing is, like, once you can do stuff like this, because I tell you, these are the kind of things that give you confidence when you go. For example, I remember when Paul was with us last week, right? Paul, the Paul guy that he said
Uh,
gave me a lab. Even though after Paul gave me the lab, I wasn't able to complete Paul's lab then. But I tell you, like 2 weeks later, I went for my CCNA because it
hmm.
gave me so much confidence that if I can, just the fact that I could attempt the lab and go as far as I did, there's nothing that Cisco can throw at me in the exam that I won't be able to handle.
Yeah,
Right.
guys, I'm also appearing. I register my exam on 13th of March.
Nice
So
one,
if you
man.
have some kind of labs, so
Yeah.
please go ahead and
And yeah, I will probably do that. It will probably give you a challenge lab because what that kind of thing does is that even though you may not complete it, but just the fact that you can attempt it, it gives you a confidence that they can't throw anything worse than this. So
that's my
again,
email, and it's very easy email to remind.
nice one.
Just
Okay, we'll do. I'll do. Okay, so let's make this like the final example of this particular scenario. So which one do you think would be the root port for switch D? So now we've
root
got
for.
We've
Okay.
got this cost here is 100. This cost here is
Yeah.
19. This cost here is 19. This cost here is 19. So this
Oh,
one
geez.
is 4096 priority, CCC mark, 32768 priority, BBB mark. So switch D now has this all this all this scenario to look at to determine what
Okay.
will be my root port.
Okay, just first of all, just let us know because you put 4096.
Yeah,
In this case, the root A, it has 4096 priority or 0. It cannot be more than that because
yeah. So
then,
yeah, but let's say this one is the root. Let's say for some reason it's got 0.
okay,
So it's got 0. Yeah.
okay.
So switch D has to decide what's my root port. What's the best port for me to go out and get to the root. Okay, power even wants me to. Okay, let's do that. Power wants me to take this one away and then let you guys start from C. So what's the root port for switch C?
A root port for C will be, it's 100, it's 19, 19. So I will say it's number 4 is the root.
What do you think, Mark?
Yeah, I mean, based on path cost, that would
Good
be.
one, very good one. Thanks for giving me the reason. Based on path costs, the one will be this one, right? Root
Mhm.
port based on path cost. Okay. What about switch D?
Switch D
D
path cost will be the root port will be 8.
8. Mark, what do you think?
Yeah, I think that's the same thing. If you base it again on path cost.
Good one. So now you're understanding it, right?
Yeah.
Path cost. Okay. What about switch B?
Say 5 would be
Yeah, what do
same
you
thing
think,
because of
Imran?
path.
Of course, it's number
Yeah,
5.
good one. Very, very good one. So you understand it now. So now, if the path cost, if you can't just get it based on path cost, then you move to what? Priority. Then you move to what? MAC address. Then you move to what? Advertising port number. So that's clear. So now, okay, now we have this scenario where we have all our root ports. So this guy's like, this my root port, this my root port, this my root port. So now for the root, every port on the root is designated.
Yeah.
And this will help you to understand what I was saying. So this port, every port on the route is designated. So the thing is, for every network segment, there has to be one designated port, just one. So for this one, between 1 and 2 is a segment. There can only be one designated port. Between 4 and 6 is a segment. There can only be one designated port. Between this one and this one, it's a segment. There has to be one designated port. Well, actually, there can be more than one designated port, but again, let's go over it slowly. So this one is designated port, right? And
Hmm.
this one is the root port, and then this one is the root port for switch D. So this one will also be designated port. It can be blocking because it's connecting to a root port. If you're connecting to a root port, you can't be blocking.
All right.
You have to, because that means this guy is like, if I want to talk to the root, I have to go out from port 4. If port 6 is blocking, what would that mean? That means you cannot get to the root, right? So if you're
Hmm.
connected to the root port, you are automatically designated. Imran, is that
So,
clear?
yeah, so you mean when they ask question in the exam about the you have to find the blocking port, like they say,
Yeah,
find us the blocking port.
yeah.
What port will be the blocking? So in this case, you the main thing what I got from you,
Mm,
first decide which is the, yeah, okay, root both are designated, and then rest you decide which are the root
mm,
port, and then you go to to the link where both are designated,
mm-hmm.
and then you have to break the tie, and who
Exactly.
wins.
Good one. Exactly. So basically, if the port is not, if the port is not, very, very good one, Imran. Actually, you just gave another method right now. So if the port is not a root port, yeah, just mark everything as designated. So mark everything as designated. right? So Mark, so I go designated, designated, designated. This one is root port. So now the segment where both are designated, one of them has to block.
Hmm.
So this one will be designated, but it's connected to a root port, so it won't block. So this segment where both are designated, one of them has to block. So that is the place where you have to decide which one will block. I'm not sure if that is clear.
Yeah, and here if somebody has the more cost,
So exactly. So which one will you think will block here?
here I that's here is clear. Two will be blocked because root cannot be blocked.
Exactly.
Root
Very,
switch
very,
cannot.
very, very good one. Mark, is that clear?
Yeah, I got that part. I'm
Yeah.
just not sure which one. Oh, okay, yeah,
Yeah.
because we're not going to be going down that 100 path
Yeah.
at all.
Exactly.
So,
And then we're not going to be blocking the root, any port on the root. So it too has to block.
right.
So in this case, so let's go back to this case that we had. So in this case, can you figure out which one will be designated, which one will be blocking?
One and two root is which
No,
one?
this one is the
Root.
root. What is this one here?
Okay,
Yeah.
5 and 6 will be designated.
Yeah, designated.
4 and 1 will be root port,
Yeah,
and
good one.
3 and 2 will be designated.
Yep,
And now we are break the tie between 2 and 3
yep,
for the blocking port,
yep.
and then we will go to the cost path. And let's say both are 100, so by default, then we will go for the
So you're right, Imran, but then the last explanation that you're giving, so this is where we have to break things down and make things clear because there's a lot of election and things going on in spanning tree, which we
Mhm.
have to we have to make clear. But you're right in terms of now we've decided first thing we decide is which one is our root port, right? So these are root ports, these are root port. All the ports on the road are designated. So this designated port, this designated port. So now the section that now has all the ports designated, one of them has to block. So when you're talking about this one, this is another election all the way. So this is not an election of you start from path cost. This is an election of you start from bridge ID. Or bridge ID determines which one will block. You get the
Bridge
point?
I. Oh, so Mac plus priority.
Priority plus mark, yeah. So
Yeah.
priority first plus mark. So if this one has the lowest priority, so they both have the same priority, but this one has the lowest mark. So that means
yeah,
two will be like, yeah, I've got a better
3
bridge
will be
ID than
block.
you.
Yep,
Exactly. So three will block. So I'm not sure if that is clear.
it's
Wait,
clear.
3 is blocking? Oh,
Three will blocking. Because this one has what?
mhm.
So why will three be blocking? Because number two has a lower priority plus mark. Because the priority are the same for both of them, but the mark is AAA, whereas the mark of this one is CCC. Is that clear?
Yeah, kind of. Um,
So,
I,
Mark, what's the question that you have about this one?
no, well, okay. So you're trying to figure out they're all. Let's see. You got root.
So again, remember
Uh,
that this time we're not talking about spanning tree because spanning tree. Let's go from this. We're not talking about spanning tree port state. Yeah, we'll talk about this one. We're talking about spanning tree port rows. The rows. So we're determining which port will be root port, which port will be designated port, which port will be block port. Yeah. So I know that it sounds confusing because under the spanning tree port state, there's another port state called blocking, right? So that can make
mhm.
it sound confusing. But let's forget about port state for now. Let's talk about
Okay.
just port rows. So where we have all our spanning tree topology, all our switch topology, we want to determine what will be the port row for every switch port in that topology. Yeah, no
So
problem,
when you're
Imran.
doing that, the last thing there, we were trying to figure out which is the blocking port. You
Exactly.
really the lowest one is actually just going to become the designated port, and then whatever the other one that's left over on the other side will be the blocking port.
Yes. So think about it. Let me think about it. Mark, think about it this way. So all the ports on the road are designated.
Hmm.
Now every other switch that is not a root has to determine one port that will be their root port. And that port has to be the best part that will take them to the root.
Hmm.
And the way they calculate that is the part cost, or you know how what's the effectiveness if I take this road or if I take that road. It's like the same way when you're like, if I take this road to get to the town center, or should I take this road to get to the town center? They're like, this road is faster, it has less potholes. I'll take this road. So they have to decide that. So based on that, they will select one route port, right?
All right. Right.
So every other port that is not selected as a route port, mark it as a designated port.
Hmm.
So any segment where you now have two designated ports, one of them must block.
All right.
So if you have root port designated ports, okay, root port designated port, okay, but if you now have two designated ports, one of them must block.
And
And the
that's
one that will block is what? The one that has the lowest bridge ID.
what's bridge
Or the
ID.
lowest bridge ID is simply priority plus mark.
Yeah, but then how come the other one's turning to block?
Yeah, because this one, if you look at this one, it has the lowest, even though they have the same priority,
Mm.
this one has a lower MAC address than this one. So this guy will tell this guy that, okay, we're both designated, one of us has to block. I have the lowest MAC address than you, so you have to block.
Okay. Okay. I
So
got
this
you.
one will now change this port row to block. So if you go
So
back
he's
to,
going to tell that one that he's blocking.
yeah, yeah, exactly. So this one, so basically what they're doing, again, remember that the whole way that all these things are happening is something called BPDU, which is they are exchanging information.
Hmm.
So, and the information that they're exchanging contains some content. So the content includes if this one sends something, if switch A sends BPDU to switch 3, the content of the BPDU will include the priority, the MAC address, right?
Hmm.
So this one is like, okay, if I'm designated and this guy, this on the end is designated, so that means one of us has to block. Then it's going to compare the value that is coming from the other guy with its own value. And it's going to be like, okay, I've got 3268. Oh, you've got a lower MAC address than me. That means I have to block. So they all know the rules. So they're just comparing the values with one another.
Right.
It's the same way that if you've got, let me go back here. It's the same way in the beginning of spanning tree, when you have three switches in a topology, in the beginning, everyone starts out announcing that I'm the root bridge. Everyone. So it's the same way, but they all understand the rules. So this one goes, so switch A will go to switch B and say, switch B, I'm the root bridge. And it will go to switch C and say, switch C, I'm the root bridge. Switch C will also go to switch A and say, switch A, I'm the root bridge, and go to switch B and say, switch B, I'm the root bridge. And switch B will do the same thing. But then when this one gets the value, this one will go, okay, hold on. Switch B, you've got a priority of 0. This one, you've got a priority of 4096. This one, you've got a priority of 32768. So when switch A starts, switch A will say, I'm the root bridge, right? It will say that to switch B and switch C, right? Then
Yeah.
switch C2 will reply and say, I'm the root bridge. And switch B2 will reply and say, I'm the root bridge. So when switch A receives the BPDU from switch B, it's going to be like, okay, hold on. You have a lower priority than me. I can't be the root bridge. Therefore, I will stop advertising myself as the root bridge and start advertising you as the root bridge. So
All
that's
right.
the way the whole spanning tree works. So they're all exchanging information and comparing with one another. So switch C will also now receive the BPD from switch P and go, hold on, you've got a lower priority than me. That means I cannot be the root bridge. Then switch C will now start advertising to switch A and to any other switch that is connecting to and start telling them, I'm not the root bridge. There's a switch here called switch B that has a MAC address of BBB and has priority of 0 and it is the root bridge. That's why you have sender ID and bridge ID. You get the point? Is that clear,
Yep.
Max? So
Yep.
because the bridge ID is saying in the beginning the bridge ID and the root ID will be the same because everybody is advertising I'm the root. But then as they are going, it will be like, hold on, I'm not the root. There's another switch that has a lower priority than me. So I will stop advertising myself, even though I will still put sender ID and say this information came from me. But I will stop advertising myself as the root. I'll start advertising you as the root.
Yeah, that makes sense.
Yeah, so it's just comparing values. It's the same thing that is going on in this scenario. Switch 2 has received the BPDU from switch 3, or switch A has received the BPDU from switch C. So switch A is comparing the values and is like, okay, hold on, I have a higher, um, I have a lower MAC address than you. You know, we all know the rules. I have a lower MAC address than you. That means it cannot be my port that is blocking because you have a higher MAC address than me. And when switch 3 receives it, switch 3 is like, okay, hold on, I have a higher MAC address than you. You cannot be the one that's blocking. That means I must block one of my own ports. And then it blocks this one. You get it?
How does he block that other port? Or
So a good question. So the blocking is not as if it disables the port.
Mhm.
It simply puts a software block. So it's just a software block that it puts. In other words, it's just a condition, a software condition that says blocking simply means this. This is what blocking means. It means I won't transfer any traffic. I'll just be receiving BPDUs. So in other words, I won't be transferring any traffic. In other words, this one will just put this port in a state where no traffic will go out from it.
so the AAA is, it's not really blocking it, it's telling CCC to block it.
Yeah. So it's not even gonna. It's not as if it's telling it like that. The way
Mhm.
it tells it is by giving it the information that it needs.
Okay.
So it's like this information is coming from me. It compares it. So when C receives it, C compares the information it has received with its own information. It's like I've received an information from a switch called A from my port 3. And the switch has this priority and it has this MAC address. I have this priority, I have this MAC address. Oh, this switch has a lower priority than, sorry, has a lower MAC address than me. So in other words, I will be the one to block because they know the rules. Protocol is a language where it has rules. So they all know the rules and they know once I receive anything lower than me, I have to make the right decision. Is that a bit clearer, Max?
Yeah, yeah.
So then if you go back, let's go back to packet tracer. It's not as if it's like disabling the port. So the port is not disabled. The port is still working, but only that no traffic is passing. So if I go show spanning tree VLAN 1, and then okay, so this is the route. So how the ports are designated, right? So
Hmm.
let's look for the one that is blocking in the diagram. So yeah, this switch is blocking. So let's go show spanning tree VLAN 1. So you can see, um, actually we'll come to this one later. We'll talk about we'll talk about this one later. The port rule is alternative, but we'll talk about that one later because yeah, we'll talk about that one in a bit.
So which like if you compared this to the drawing, which switch would this one be? This
So
would be the other one, right?
yeah, so let me go to this drawing. Let's go this drawing here. So this one will be switch 3
Oh, C. Okay.
because this port is blocking now.
All right. So it's just gonna send that message out saying you need to block it,
Yeah,
or is it? Okay.
yeah. So yeah, so basically once the two of them are designated, they have to decide someone has to block.
Hmm.
And then it goes, oh, I've got a lower MAC address than you, so you have to block. And then the other one goes, yeah, it's true, you've got a lower MAC address than me, I have to block.
Yeah.
And then just put this in a blocking in a yeah in blocking mode. But we'll come back to that one. So let's go a bit further now. So The thing about spanning tree also is this other thing called port states. So we just talk about port rows, right?
Hmm.
Is this thing called port states, and port state is a bit different. The thing about port state is these are the states that the ports go through before they start forwarding traffic. So every port starts out in the disabled port port state. Every port. For example, you have a port here, you've not plugged any cable in, or maybe the administrator has shut it down, so it's disabled, right?
Right.
Yeah. Then it goes from disabled to well, normally you say blocking there, but let's say it goes from disabled and it's not listening or learning. Let's rearrange this. Let's go delete. Let's go disabled, listening, learning, forwarding, or blocking. So it goes from the disabled state, and when you switch it on, it goes to the listening state. So look at this. If I go
Hmm.
here, if I go to, so this is the diagram. We've got switch 1 here. So let me shut down port F802 on switch 1 or switch, yeah, switch 0, switch 1, yeah, switch 1. So let me shut down on switch 1. Let's shut down port F802. Conf T interface first 02 shut. So I've shut down this interface F802 on switch 1. Now let me switch it back on now. So let's go show spanning tree first 02. Oh, okay, we need a do if we're in this mode. Yep. Okay, so you can see it's shut down, right? Then let's go no shots. And then let's go. Now look at that. Look at the row. The status. Sorry, not row. Listening, right?
Oh, let's. Yeah.
Yeah, let's see. Still listening, right?
Because you
So,
just turned it on, so.
yeah.
Right.
So it's listening. Now it's learning, right?
Oh, look at that.
Yeah. Now it's learning, 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 learning. How long do you think it's gonna be that it's gonna stay in learning?
15 seconds
Good one.
of forward.
Very good one.
Oh, forwarding. There it
Yeah,
goes.
now forwarding. So now it has to go through the different roles. So the first thing when you switch on a port is that it starts to listen. Now the question is, what is it listening to? So let's go listening. What is it listening for, Imran? So you switch on a port, you go from short to no short, then it goes to, oh, now I'm listening. I was disabled before, right? So that's the
Yeah.
first one. It's like I'm disabled before, but now I'm listening. What am I listening for?
BPDUs.
Good one. I'm listening for BPDUs. I'm like, will I receive any BPDU from the other side? That's what I'm listening for. So in this state, this port cannot transmit any data.
And it will not learn any MAC.
Exactly. It cannot learn any MAC address. The only thing it can do is send and receive BPDUs. That's all it can do. Then after that, listening, the other thing it's going to do is move from, which one is the next one I did, Mac?
Learning.
It went to
Oh,
learning.
oh, sorry.
So,
Sorry. Let me put my MAC.
yeah. So what is it learning? Mark, what do you think it's learning?
Um, who's the root?
No, it's learning MAC
Uh,
addresses.
oh, actor. Okay. So,
Yeah. So it's like now I have to start putting values in my MAC address table. If anything, if any device is on the other side, don't worry, Mark. Next time you hear this, believe me, you'll be glad that you listened to this one because it will be much more
yeah.
easy. So now it's learning. It's learning MAC addresses. Then after that, it goes into either forwarding, in which case now it can start transmitting data. It goes into forwarding or it goes into blocking.
Either
So
one of those.
yeah, either one of those. So that goes into forwarding or it goes into blocking, and it goes into blocking based on all the things that we discussed earlier, whether I'm blocking, I'm forwarding, and all that. So it goes into forwarding or it goes into blocking. Now the thing with this port state is this: it is good. It's a good thing, right? Because it's listening for BPDU, it's learning. The thing with this is that if Mark comes into the office and Max takes a PC and Mark takes a cable and plug it into the switch, you know what will happen? This port that you just plugged into will go from not functioning to functioning, right?
Hmm.
And you know what will happen? It will go through all those states that we just talked about. It will go to listening and learning and forwarding or forwarding and blocking. Oh, yeah, definitely won't be blocking because it's a PC, it's not a switch.
All right.
Now, is there any purpose? Is there any benefits to that?
So
Yeah, thank
what? The
you.
listening?
Power said, yeah, for example, look at this. Let me take a PC, right? Let me take a PC. So this is a computer here. So I have a computer here. Now, or let me take a computer to this guy here. And let me plug a cable to this switch port here. Now look at, you can see that it's amber, right?
Hmm.
And if you go to this switch, it's actually going through listening, learning. It will take 30 seconds before any traffic start passing from this PC to the net through the network. I'm not sure if that is making sense. Because
It
now,
has to learn the.
yeah, so it's going through listening and learning. Now you can see it's green now. You notice that it's green now.
Isn't this what that port fast does? Where
Yeah, exactly.
it does it?
So yeah,
Okay.
thanks very much, Power. So Power said, yeah. So here's the point: is that the first thing it's doing is it's listening, right? What's it listening for?
The BPDUs.
Will he ever hear any BPDU from this port?
No, it's access port.
Exactly. So it's wasting 15 seconds listening for something that it will never hear, and it's going through all that process all the time. So actually, you can see all the timers here. If I go um, show spanning tree summary, I think. But maybe not summary. No, maybe not summary. Show spanning tree. Let's just go to show spanning tree. Um, yeah, look at this. We've got an LO time. We've got a maximum age. We've got a forward delay time. LO time is how often I send BPDU. So BPDU will be sent out every 2 seconds. Forward delay is the time that I will spend in listening mode and in learning mode. So that's why they spend 15 seconds by default. So you spend 15 seconds listening for BPDU, 15 seconds learning MAC addresses. So that is learning. So that is the forward delay timer is what sets that. Then the maximum age. What is that about? Imran, what is maximum age about?
Maximum age is before this router it will declare as a dead.
Yeah.
That
So yeah. So
he has
maximum
to look for another path.
yeah. So to make it clear, Mark, so maximum age is if I don't hear anything from this guy, so I'm expecting, BPDU every 2 seconds.
Hmm.
If I don't hear any BPDU, from this guy, after 20 seconds, I will remove all the BPDU that this guy sent to me. And I will go through the process of, you know, learning what's going on the network again.
It's pretty impatient, huh? 20 seconds.
20 seconds is really, really slow actually.
Yeah.
Which is the whole reason, which we'll get into, which is the whole reason why we have a new protocol called rapid spanning tree, which is not like a new protocol, but it's kind of like an improvement to spanning tree.
Hmm.
Because people were like, we have to go through all these 15 seconds to listen to what we don't need. Then we have to go through like all this learning and all these different modes, and then we have to go through if we miss any BPDU, we still have to wait for 20 seconds before we remove the record from the table. Then that is 30 more seconds to now start going through listening and learning, and all that stuff again. So that is at least 50 seconds. So that's like the timers that spanning tree uses. But in the network, it's advisable to after you configure spanning tree, there are two more things that you have to do, and those things that you have to um, I call it tweak spanning tree or make it more
Options.
yeah or make it more efficient. I think. So first thing you do is you configure spanning tree. Next thing you do is you tweak it to make it more efficient. Next thing you do is you protect it. So that's the next thing that you do. So the way you tweak it, one of the things that you have to do is configure the one that Mark mentioned, which is called port fast.
And BPDU guard.
Yeah. So PPDU guard will fall under protecting.
Yeah.
Yeah, which we'll get to. So actually there's B for the CCNA, there's BPDU guard. There's Mark, any other one that you to protect spanning tree? There's loop guard. There's root
But
guard.
I don't see anything else. I'm
are the
looking.
CCNS stuff? Because we in NetAcad, the courses, we only learn about port fast and PPD guard and
Ah,
loop guard, uplink guard. I don't know how many guard they
yeah,
say.
there are quite a few guards. Actually, one of the things that you find out is that many of these things have been superseded by rapid spanning tree. Well, not
Yeah.
all of them, but many of them. But yeah, we still talk about them just for the sake of the exam. So, for
Okay.
example, and it will help also to understand rapid spanning tree. So, the first one, port fast. So, what's the purpose of port fast?
Just to skip all this learning, it put from directly block to forwarding stage, so it
Ex-
doesn't lose any time. Yeah.
Exactly. So,
Yeah.
for example, instead of going through, let's actually go to this switch. So remember what happened when we went to this guy here and we connected the port. It took 30 seconds before it became green. So again, let's do that again. So if I go delete, cancel, let's just go delete, and let me delete this port, and then let me connect a new port. Let me connect it to this guy. Now you see that it's amber, right? And it's going to go
Hmm.
through listening. So that's switch to. So I do show if I catch it enough. Yeah, so you can see it's listening, learning now, right? And then it will start forwarding very, very soon. So what I can do is I can go to this switch and say conft. There are two ways I can enable port fast. What are those two ways, Imran? There are two ways that I can enable port fast.
You can put globally, or you can put interface.
Good one. If I want to do it globally, there's something that must have happened first. There's a little thing I must be careful about if I want to enable it globally. What's that?
It's it's
Trunk ports.
no
No,
trunk
Mark.
trunk
Thanks
cannot.
very much, Mark. So all the ports that are
Yeah.
that are going to be connected to client, I must set them statically to access port.
Access. Okay. Yeah.
Oh.
Otherwise, port fast won't work on them. Actually, if I go spanning tree port fast, yeah, and I go default. So you look at it, it says default. Enable port fast by default on
Okay. Yeah.
only all access ports. So
Yeah.
if I leave the port in DTP mode, which is dynamic trunking protocol, where they start setting dynamic disable or something like that, if I leave it in that mode, I'm getting into, it won't work on them. It will only work if the port are set to static access.
Yeah.
So I have to make sure I configure the port for static access, then I just go spanning tree port fast default. Or I can do it, which other way can I do it? Imran, which other way? Which other way can I enable port fast?
You can go to interface
Yep, interface.
and then just put spanning tree port fast VLAN.
Yep, port fast, yeah, and that would do it. Or yeah, I can do it for either what this is packet tracer. I can do it for a specific VLAN, or I can do
Yeah.
it yeah for all VLANs for that. Okay, so that's like the two ways to enable it. But always remember that if I want to configure it globally, I have to go, interface and then go switch port mode access. I have to configure this one first, then I can go and go to this one and go spanning tree, spanning tree port first default, and then that will enable it. So in this case now, if I remove this one and remove this port and then connect it back, look at what will happen. Boom, instantly the green. It's not listening and learning and doing all that kind of stuff. It just goes straight to forwarding. Now there's a danger here. What's the danger here?
If someone hooks a switch up there.
Good one, Mark. If someone go, if one of, because now we've done one of the things that we have to do. So again, when you're configuring spanning tree in your production network, remember three things you have to do. You configure it, right? You have to configure spanning tree for all the switches on your network. There's no option. You have to. So that's my wife. Let me go. Let me go. There you go. Okay, no problem, guy. No, not
You're in
really.
trouble now.
Yeah. Yeah, cause she's
Welcome to my world.
I know your word, man. I've lived in your world for a long time. I'm not sure. I'm not sure. Mark, you're married, right?
No, not anymore.
Ah, okay. That's why. That's why you're smiling. That's why you keep smiling all the time, man. Oh my God, my wife is in the. No,
We can do it later if
I
you
didn't
have
mean
really trouble, David.
I didn't mean that at all.
We-
No, I didn't mean that. I mean, I have to
if he's
apologize.
if he's not here next week, we know what happened.
Exactly. You have a recording of the Hangout
That's right.
yeah. Yeah. So yeah, let me go back to sharing my screen. So that's like the thing. So now we've made spanning tree more efficient. So first thing we have to configure spanning tree. Next thing we have to make it more efficient because there's no point, enabling spanning tree on ports that doesn't need spanning tree, like all your access port. They don't need spanning tree. But then after making it more efficient, we've now made it more dangerous. So now the next thing we have to do is we have to protect spanning tree. We have to protect it. Otherwise, we'll be receiving calls every time. And the ways to protect it, which is part of the things I mentioned. Number one way is BPDU guard. BPDU guard, what does it do, Mark? Or what does it mean?
I mean, it'll protect that port from receiving any BPDUs or processing them, or
Yeah, good. No, that's a good answer actually. From receiving BPDUs. So that's right. Imran, do you have anything to add to that? So BPDU guard. So that's a very good answer already from Mark.
BP2 is card just if somebody plug in on access port somebody put some switch to make it like put configure the priority down to make a root so it will disable
Yeah,
it will protect with
good
that.
one. You've added something. The one I was looking for you to add, you've added it. So that is what will it do when you receive BPDU? It will disable the port. It will put the port into the error disabled mode.
Uh,
Yeah, so that's what it will do. So if I go to that port now, and let's go back to this one. So the port is interface fast03. Go interface fast03 and go. Now I can. There are two ways for me to enable PPDU guard. What are those two ways, Mark?
to enable the PPD,
PPDU guards. There are two ways.
I'm not sure.
Yeah. Imran, what do you think? Moga. Imran, what do you think? Two ways to enable PPDU guard.
Uh, I think I just learned. I think you can globally plus interface, and this is the same on the access port. You have to access it, make it enable.
Yeah. Yeah. Good one, Imran. And yeah, that's a good, really good one. If you look at this though, when you're configuring it globally, you do it under port fast. So you
Uh,
have to go spanning tree port fast. So, well, surprise, surprise.
No, you put spanning tree BPU guard enable.
Is it?
Yeah.
And oh, sorry, maybe spanning
B,
tree VLAN, VLAN 1. I was thinking it's under port fast. Yep, VLAN 1.
it doesn't even
Uh,
show it in the book on how to.
actually, no. Actually, let me just
you
confirm.
go spanning tree BPDU guard enable. Put that command, please.
Spanning tree, no, it won't work. Because if I do spanning tree and I do question mark, there's no option because it could be because this one is, we're on
Because I
packet.
was actually practice on the real one.
Yeah.
The real then.
So spanning tree BPDU got enabled on
You
the.
have to be on in the interface command.
Yeah, so
Can you
that's
go
on
to
the.
interface?
But there are two ways to configure it. You can do it on the
Ah,
interface, you can do it globally. So if you want to do it globally, you have to do it from under port fast. So you go spanning tree port fast, and then you go after port fast, you can do BPDU guard enable, and that will enable it for all ports that has port fast. So, but this is not available on Packet Tracer. But if you have like a view switch, if you type this command, spanning tree port fast BPDU guard enable, you can enable spanning tree, BPDU guard globally that way. The other one is the one that Imran mentioned, which is by interface on a per port basis. So if I go interface um, fast 03 and then go spanning tree BPDU guard enable and I go enter and that's it. So there are two ways. Globally, you have to configure it under port fast or locally. Yeah, good one. Uh,
This port fast should
Okay.
only be.
Actually, Powell is mentioning something. Powell says spanning tree, port fast. Okay, is that from the config mode? BPDU guard. Yeah, okay, yeah, without enable. Yeah, that's right. Yeah, that's right. Yeah. So that's from the enable. So if you're doing it globally, spanning tree, port fast, BPDU guard would do it. If you're doing it globally, if you're doing it by port basis, spanning tree, BPDU guard enable, and that will enable it. So what will now happen in this case if we go back to our topology? And let's remove this one, and let's be like one of our typical users with the switch port. Why? I'm coming. I will have a look at it for you. I'm coming. I'll have a look at it for you. Okay, so we got this one. So we got the switch here, and let's plug our switch into, let's go a crossover cable. Let's go fast Ethernet 01, and let's connect it to fast Ethernet 03. And let's see. Yeah, look at that. Boom. Can you see what happened? Change the stage to administratively down. And it tells you
Okay.
the reason. It said received BPDU on port fast Ethernet 03 with BPDU guard enabled, disabling port. So if I go show, or if I go and to show IP interface brief fast Ethernet 03, if it allows me to do that now. Yeah, just to, yeah. And then fast Ethernet 03, it says down, down, but if I go escape, um, exit, exit, and then do show. Maybe. Okay, and then let's do show. Um, show spanning tree. Mm-mm. Ah, okay. Yeah. I'm coming. Actually, I'm coming, baby. I'll come check to have a look at that. Does anyone remember the command if you want to see ports that are ever disabled? What's that command again?
To see one that's disabled?
Yeah,
Or
that's error disabled. Show interface so three. So I know it should show it here somewhere, but there's another cool way to show it. So it shows it that it says error disabled.
show in status, he says. Oh, without packet
Ah,
trace.
okay, but not on packet tracer. Okay, yeah, packet tracer. Show instead of yeah, no, no, I missed something. Show, yeah, that will explain why it didn't work. Show interface status. Yeah, okay, but that's one way. So it actually puts it in error disabled state, and what will happen is that this port will remain disabled even after you remove the switch. Oh, sorry, I removed too much. I didn't mean to remove all that. So even after you remove this cable and all that, this port will still remain in error disabled state. So that is BPDU guard. The next one is loop guard, which we won't go into much details about because what loop guard does is a bit more complicated to explain. In this case, when this port, remember when we're talking about this one, this port is blocking, right? But this port is designated. Now, this port that is designated here will still be sending BPDUs to this port that is blocking, right?
Mhm.
It's still sending BPDUs to it, even though it's blocking. But what happens if, for some reason, this port stops sending BPDU to this port? What will happen is this port will just go through the listening, learning state and just go to forwarding. But what could have happened is that maybe the reason why this one is not sending BPDUs could be maybe because there's a filtering going on somewhere. So it's not as if this port is not active, but maybe firewall or something, or there's a filtering going on somewhere. I'm not sure if you get that. And then all of a sudden, this guy is like, I'm not receiving PPDU. So instantly, I will just go straight to start, I'll go through listening, learning, and I'll start forwarding packets. So loop guard is a way to say, hey, this port, I want you to remain in blocking mode. Even if this port goes away from designated, so not goes away from designated, even if you don't receive BPDU from the guy that is upstream, don't start sending packets because the reason why this guy is not forwarding could be because a filtering is going on. Maybe it's not actually down. Maybe a filtering is going on. I'm not sure if you get that.
Yeah. Yeah.
Yeah. So that way, this one will go into something called loop inconsistent mode. So it won't disable it. And the moment this guy starts sending BPDU again, it will go back to blocking mode. So let's actually try to do that one quickly. So if I go back to this one, so remember this one is the one that's blocking, right? Port F801 on switch 1. So let's go to enable conft and that's port F801. Mm, spanning tree guard. Okay, there's no loop guard on packet tracer, sorry, so I won't be able to demonstrate that. So the command is spanning tree guard loop, and that's like spanning loop guard. So loop guard will just say, oh, I'm supposed to be receiving BPDUs from you. I'm not sure what happened. I'm not receiving BPDUs from you, but I'm not going to, because of that, start forwarding. I will just put you into a state called loop inconsistent state. And if I start receiving BPDUs from you again, I will change it back to blocking, but I won't start forwarding. So that is loop guard. But then the last one, which is tree guard. Ah, sorry, root guard. Root, root guard. So what does root guard do?
Oh, God. I don't even see that in the book.
And Imran, what does root guard do?
I have no idea because I just read about only BPDU
Guard,
guard
yeah.
and
Actually, BPDU guard, root guard and BPDU guard are a bit similar, but the main difference is this. Root guard will only stop you if you advertise that you're the root. So root guard will be like, I'll allow you to send BPDUs, but the moment you start sending a BPDU that says, I have a better value than the current root, I will stop you. Yeah, exactly. So better bridge ID. So the moment you start, for example, this switch has a record that switch B is the root, right?
Oh, okay, that
So
makes
switch B
sense.
has a record, which is like, yeah, you're the root. Now switch C is like my root is a switch called BBB, his MAC address is BBB, his priority is 4096. Now somebody plugs a switch in here and the switch is like, my priority is 0. The moment this guy receives it, is like, no, sorry, you're not going anywhere. I'm stopping you. But if this guy goes and goes, my priority is 32768, it will allow you to keep functioning. It will allow you to go through listening, learning, forwarding, and all that stuff. But the moment you start trying to advertise a value that is better than the current route, I will stop you.
Hmm.
And it works similar to loop guard. It won't actually disable the port. It will put the port into a state called route inconsistent. And then the moment you stop advertising that better value, I will allow you to start going again. So that one we can do on Packet Tracer. So if you look on Packet Tracer, if you go, so this one, um, we can go this switch, and let's go to switch 2. Let's go to F803 on switch 2. Um, or let's do F804. Uh, interface first 04 spanning tree, and root guard I think can only be enabled on a per port basis. You can't enable it globally. So if I go spanning tree guard root on port 04 of switch 2. So we've got this switch here, switch 4. Let's see what switch 4 values are. So if we go, so we do show spanning tree. Yeah, no spanning tree because yeah. So let's go plug this one into port F04 of this switch, F04. And then it goes through listening and learning and doing all that stuff. And then even though root guard is enabled, let's see what happens. Remember that root guard is enabled on this switch. Ah, look at this. Can you see?
Oh, okay, yeah.
It has moved it into root inconsistent state. So what that means is that this switch must have been trying to advertise, switch 4 must have been trying to advertise that I'm the root bridge. So if I go conft show, sorry, to show spanning. So let's see, its MAC address is, yeah, so definitely it's advertising itself, but its MAC address is 00C CF122A89. Let's compare that with this guy. What this guy says, to show spanning, and that is 00. Yep, that's why. So look at this one. So the current root is 00. Oh, sorry. Let's bring this one back and let's go to switch 2. The current root is 0030, right? Look at switch 4. Switch 4 says is 000C, which is a better value, right?
Uh,
Yeah, because it's 000.
03 is the better.
Yeah, no, 000 is lesser than 003.
yeah,
Yeah,
you're right.
Yeah, so
yeah,
it's like, yeah,
3
you're
is
trying to,
better.
but let's do something to this. Let's change the priority to something higher. So let's go spanning tree, VLAN 1, priority. Let's go 61440. So now it has a higher priority, right? So let's look at what happens. Now you see that this, let's see what happens. Switch 4. Let's go to switch 2. Let's do show spanning. So now it's listening, right? Now you can see it's learning now. You can see it's learning. You can see it at the top here, learning. And then let's go learning, learning. And then, yeah, now it's forwarding. So as long as you're not trying to take over the route, I'll allow you. But the moment you start trying to advertise a better value than my current route, I will put you into a state called route inconsistent. But the moment you change your mind and start behaving like a good boy, then yeah, yeah, that's what it basically says. Like, yeah, when you start behaving like a good boy and stop trying to say you're the root, nobody will need to come and type in, no short, I'll allow you to start functioning again. But as long as you start going, hey, I'm the root again, I'll block you. So that is root guard. So I think just to quickly end the discussion today is, so most of this has been superseded by something called rapid spanning tree. And I think the main thing to notice are the port states. So the port states in rapid spanning tree. Does anyone know what they are? So in spanning tree, we have disabled, listening, learning,
It puts them in either
forwarding,
forwarding or blocking.
blocking. Yeah. What about rapid spanning tree? What are the port states?
It's forwarding or block.
No problem, man. See you, man. So we got,
Okay, see you guys.
yeah,
And please don't forget if you have any challenge there for me.
yeah, no problems.
I just wrote my email in the chat, so
Yeah,
you can see.
yeah, sure.
Thank you very much. Have a nice day. Bye
Yeah,
bye.
no
All right,
problem.
see you
Yeah,
later.
see you, man.
Bye.
Yeah, see you, man. So we got discarding and we got learning and we
Oh,
got forwarding. That's all. So
I was just
discard,
looking in the book here, and it says under rapid STP places each port in either forwarding or blocking, although RSTP calls the blocking state the discarding state.
yeah, exactly. So what happens is that the blocking, the listening, the disabled are all put into one called forwarding. So it
Oh,
goes
okay.
disabled plus blocking plus um plus listening, everything. It just puts everything into one single state called discarding. And then it does a lot much more than that, which actually we don't really go into details in it in CCNA. I think CCNP is like it does a lot of information about rapid spanning tree. It goes into a lot more details, but that's like the main basics. Is that the main thing to remember? Cisco likes this question a lot about discarding, about the port states of rapid spanning tree. Just remember, it's discarding, learning, forwarding. That main thing. So it's not going through all this listening 15 minutes, learning 15 minutes. So when the port comes on, it's like, hey, I'm learning instantly. After that, I'm like, hey, that forwarding or discarding.
So it does it fast, like port fast.
Yeah, exactly. But then not only just does that fast, like, and port fast does fast. It also does like many other things that is not for like CCNA discussion, which is like things like, um, for example, let me just quickly see this if I can explain it without confusing you. This one, if this one, did I delete the other whiteboard? Yeah, maybe I did. No problems. Yeah, let's say, okay, maybe I can do Control Z. Okay. Okay. So you got this one, right?
Mhm.
So what happens if um this port were to fail? This one right there. So let's say this one and this link fails. So this link is this guy's way to communicate to the roads. So this
Right.
link has failed. So this guy will send an information just to make it. You send an information to this guy and say, "Hey, um, this one has failed," and the root will also communicate to this one and say this one has failed. But you know what will happen is it's not as if everything will just. It's not as if this port will just go forwarding immediately. What will happen is that this port will still spend 50 seconds before it starts forwarding. Because what will happen is like, oh, I've received an information from this guy that something has changed. But then it
Mhm.
start going, I have to wait for the maximum age. Nice one. Yes. Not really.
Oh,
Yeah,
convergence. That's why.
yeah. So yeah, exactly. So it first of all wait for the maximum age, which is 20 seconds. So it's like I'll wait for 20 seconds, um, and then after 20 seconds, I'll remove the BPDU from my information. Then after that, I will now start going into listening for 50 seconds. Sorry, for 15 seconds. Then I'll start going into learning for 15 seconds. But whereas what will happen is that for rapid spanning tree will not put this port in just blocking. It's going to put it in a state called alternate port. So it's not going to be blocking, it's going to be alternate. So that's a new port role. That's one other thing to remember, the port role. So we've got root port, designated port. We've got another type of port called alternate now. Alternate port role.
Oh, I've seen those in the list there.
Yeah.
Yeah.
And the alternate port role, what it simply means is that the moment this guy comes and says there's a change, this guy will gonna be like, after 6 seconds, I will put this one straight into forwarding mode. I'm not gonna be waiting for 20 seconds to expire. After 20 seconds expire, then I'm gonna wait 15 seconds in listening. Then I'm gonna wait 15 seconds in learning. So he has this alternate port. Is like if I don't hear anything in the next 6 seconds, this port is going straight into forwarding. So the convergence is like really, really quick.
Hmm.
So it operates on exactly the same principles or same principles as spanning tree protocol, but only with some improvements to it. Because for today's network standards, spanning tree protocol is slow.
All right.
So that's why. So good
Okay.
one,
So
man. Yeah,
just a faster version of it.
exactly. So that's why yeah, it's just a faster version of it.
Yeah.
So that's like the main ones that I think that's where we have to stop for today. One thing I recommend, because from next week we'll move away from spanning tree. Actually, let me bring up the window and see what we're discussing next week. Cause what happens is there's one other one that we ought to discuss, but there's no chance to discuss it. But
Mhm.
if I go to let's go to our Hangout for next week and see what are we doing next week. Um, CCNA study group, and then events. Yeah, VLAN fundamental. So we'll be moving to VLANs from next week. So we're moving
Okay.
away from
Good.
Spanish. But here's one that you should read about, Mark, that will be useful for you because we didn't discuss it very much. Is this one, per spanning tree,
What's it called?
PVST,
Oh.
per spanning tree, and
Huh.
it's really simple. What it basically means is that you're not running one spanning tree instance for every VLAN. So you're running one spanning tree instance per VLAN. So
Hmm.
VLAN 1 has its own spanning tree instance. VLAN 2 has its own spanning tree instance. And there's a benefit to that. The benefit to that would be a situation like this now. So if I go, let me just quickly point that out to you. This would be the situation of a benefit to that. So if I go Control C and then delete all this, then do Control V, V. So let's go. So let's say in a network we have these two distribution switches, and then we are connecting this one to this one. For redundancy, we are also connecting this one to this one. So we have this type of topology in a network. So what happens is that um, this one, if um, if we select a root bridge, so let's say this port is being blocked. So let's say we select a root bridge. Let's go Control Z, Control Y, Z, Y. Let's go. Yeah, let's just right over it, and then let's go. Yeah, okay. So let's say this port is the one that's blocking Mac. So this port here is blocking. Um, what could happen in the situation is let's say we have 10 VLANs, VLANs 1 to 10. Yeah, 1 to 10. If this switch is the root bridge, this one, let's say this is the root. That means all the traffic for VLANs 1 to 10 are going through this switch. Whereas this switch is basically sitting down, not doing much.
Mhm.
But what I can do is configure this switch as the root for VLANs 1 to 5, and this switch is the root for VLANs 6 to 10. You get it?
Holy smokes, that could be complicated.
Yeah. So it's not actually not complicated at all. So it's basically you're going to this one because the way you select your root bridge is priority, right? You
Right.
just go spanning tree VLAN 1 uh, priority 0. So you're saying for that for VLAN 1 the priority of this switch is 0.
Hmm.
But you can say to this one that for VLAN 6 your priority is, some maybe say spanning tree VLAN 6 priority 32768. So it won't be the root for this one, for this VLAN 6. But you can now go on this one and configure this one to be for VLAN 1 priority 32768, but for VLAN 6 is priority 0. So that way you're using both switches. It's not as if one switch is just sitting down not doing anything.
Oh, I gotcha.
Yeah,
Like a load balancing type.
exactly. So it gives us opportunity to do,
Mm.
yeah, go between A and B. It will not be root ports straight away. There's some other mechanism. For example, if link go up again between A and B, it will not be root ports straight away. I guess Mark is probably talking about. Sorry, Power is probably talking about one of the ones that we discussed there. Like if link goes up again between A and B, it will not be root ports straight away. Exactly. So that's one. So Power is bringing up something. Remember the situation we were talking about. If this one goes down, it will take 50 seconds for this one to go. And then what Power is not saying is that if this guy now comes back up again, it won't become root port straight away. It will have to go through the whole process of 50 seconds before it becomes the root port.
Huh.
So it's just like longer. So that's why rapid spanning tree came in and all that. But again, just read a little bit more about pavilion spanning tree.
Okay.
And yeah, and then you'll be covered for CCNA spanning tree. So next week we're moving to VLANs, which will be well, let me see like the whole thing that we're discussing about VLAN fund. Okay, this is just fundamentals. Okay, yeah, we'll be discussing things like trunking, DTP, ether channels. Okay,
Yeah, that'll
man.
be good.
Yeah. I would have joined in for the lab today. We're going to be doing lab next week for sure. I joined
Okay.
in for the lab today, but I'm like, let me spend some time with my
Yeah, go ahead.
well, let me go. Let me apologize as much as I can before.
No, no, no. It's all good. I appreciate your help.
No, no problem, man. No problem. I mean, the one thing that makes it worth it is that at least people get a bit more understanding of that topic that looks complex, even though it may not be all clear now, but at least it's clearer than before.
Yeah,
Yeah,
yeah, absolutely. I
yeah,
mean,
yeah,
it'll get there.
yeah,
I'm gonna
exactly.
do some labs this afternoon though.
Nice one, man. Nice one. And also, if you're at home at one day and you're doing some labs and something, just post in the group. If anyone is available, if I'm available, I'll join in also and just do labs and stuff like that.
Okay.
Yeah. Okay,
Yeah, I'm
man.
gonna start with the ICND1
Yeah.
today, and just try to get done within the next couple weeks.
Yeah.
Take the test.
Yeah.
So
Nice one, man. Nice one. Yeah.
yeah.
The ICND one. Yeah. I'm not sure which topics are like mainly in ICND one. I've forgotten like what the main topics
Um,
are. I'm not sure. It's spanning through in ICND one.
I don't think it is. I think it's in two.
Ah, okay.
Let me see.
Okay.
Yeah, I mean the ICND1 is like basic stuff. Let's see. I mean, there's a lot of stuff, subnetting and
Ah, okay.
you know
You-
basic LAN stuff, and
yeah. You like subnetting, right?
I think it's fun. I don't
Yeah.
know. I mean,
It is fun. It's not, yeah.
yeah,
And then I'm not sure. I think VTP is there also.
yeah, I think you're
Yeah.
right. Some
And
other
stuff
stuff,
like that.
port
Yeah.
security and things like that.
Yeah. But nice thing. I mean, just quickly, just go. I mean, you don't have to rush it. You know, just go at your own pace.
Yeah,
Once you know that you're ready, go ahead and do it. Get it done. And after you
yep,
get it done, then just move straight to CCNP.
yeah, exactly.
Yeah. Yeah.
I think I'm gonna do it in two parts though. The
Yeah.
CCNA. I
Yeah.
think that'll be easier for me.
Yeah. Exactly. I mean, that's like the other thing. Paul was telling me like the other time. Paul was like, I did CCNP in 1 month. I was like,
Oh my God.
Paul, I'm not you. I said, oh, I'm going to dedicate this whole year to studying CCMP. Paul was like, 1 year? I did it in 1 month. I'm like, I'm not you, Paul. You can do it in 1 month. I know my own pace.
Yeah, I
Just
mean, but
telling, yeah.
there's a difference between just reading it and learning the textbook and actually understanding everything about it.
Yes. And then the
You
other
know.
thing that he may have like years and years and years of experience with all those advanced technologies that
Yeah.
CCMP does that made it easy for him to pick up. Whereas
Right.
I have to lab them and lab them and lab them to understand them.
Yeah, that's what I'm gonna do now that all those classes are over. I'm just gonna start hitting that every day.
Yep.
So
Yep. Nice one, man. So see you next week, guy. Thanks very much, Powell. Pamani, what happened?